Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to this channel, please do like and subscribe. Your efforts are massively appreciated. So this is a series on data pre-processing techniques where we are going to learn how to pre-process the data for machine learning algorithms. We have completed the first module of this series where we have talked about how to treat missing values. There we learned 4 different techniques, so if you haven't seen those videos, I would suggest you to check them out. It will be a great learning for you. So today we are going to talk about our very first technique, that is one-hot encoding. So first we will try to understand the theory behind it, and in the later part of the video, we will see the implementation on actual data for better understanding. So let's get started by asking the right question, that is, what is one-hot encoding? So it's widely used technique and you are going to see it a lot. So in this technique, we try to convert each categorical observation into Boolean values. If you don't know what is Boolean values, it's just 0 or 1, where 0 means there is no presence and 1 means there is a presence. So let's take the example of this gender variable, which is categorical in nature. So first look at the first observation, which is male. So in gender male column, we have 1 and all the other columns have 0 in it, which will help the machine learning algorithm to interpret that this observation is male. And the same thing you can see for the rest of the observation. Now you must be confused, like we did not have these columns in the actual data. But after implementing this technique, we see 3 additional columns. This is because this technique introduced additional columns, and how many columns it can introduce? It depends on the cardinality of the categorical variable. And if you don't know what is cardinality, you can watch my previous video. It's basically means the number of unique values taken by that particular column. So now let me summarize it what we just learned. So first, when you apply this technique, there will be additional columns added based on the cardinality of the variable. And if we take the example of this particular gender column, we have 3 additional columns because we have male, female, and others. And mind you, in the actually when we are going to apply this technique, you will have another column that is the original one. Next thing we need to know is how these values are getting populated in the newly created column, which we have already talked about, but I will going to reiterate it. So the values are getting populated using the original column. So if we look again at the first observation and we check the newly created columns, we can see that at gender male column we have 1 and 0 in both the gender female and gender others. So this way we are converting the categorical data into numerical one. Now there is one thing that we have to keep in mind during the implementation of this technique, and that is we have to drop one of the newly created columns. So why do we do that? It is to make sure that there is no linear combination exist among the newly created variables, because if we don't do this, this will introduce the multicollinearity in the data, which is something we always avoid. So now let's try to understand it with a different example, that how the multicollinearity or this linear combination exists. So let's say we have this variable which has cardinality 2. So we know that it will create 2 additional columns. And try to look at the values inside these columns. Now if I ask you a question that given one column, can you predict the value of other column? And the obvious answer is yes. And we can do this because they can be represented as a linear combination of each other. And we can see this equation pass is equals to 1 minus fail, which is a linear equation. So in simple term, if first column has 1, the other column is going to be 0 and vice versa. So it is safe to say that the same information can be represented using either of the columns. So why not delete one of these? Now the same idea can be extended to a variable which has cardinality 3. In that case, we are going to have only 2 columns. Now we can generalize this idea. So let's say if we have a variable which has cardinality n, in that case we are going to have n minus 1 new columns. And don't worry if it's getting too technical for you. You can read about linear combination and multicollinearity. These are very easy topics. Now let's talk about the advantages of this technique. So first thing, this technique is quite robust with tree-based model and linear model. So you can use it for the random forest, you can use it for the linear regression. Second thing, it keeps all the information intact since there is no data loss. We are actually preserving the information by creating additional columns. Third thing, this technique is very easy to implement using pandas. We just have to call few function and that's it. Lastly, this technique works for both classification and regression problems. Now let's talk about the disadvantages of this technique. First and the foremost one is the curse of dimensionality it brings with itself. So let's say you have a categorical column and it takes 100 unique values, or you can say the cardinality of that variable is 100. And if we try to implement this technique on that variable, we are going to add additional 99 columns, which is like introducing 99 new variables in the data. Hence, it is going to increase the dimensionality of the data. And this is something we avoid because the main purpose of doing EDA is to bring down the number of variables or number of columns, because we want only those variables which are contributing to the model. Having less variable in a model comes with an advantage of explainability. And in real world, it is not only about accuracy. We have to see how explainable our model is. And the less variable it has, the better you can explain the model to stakeholders. And in the practical section, I'll try to show you that how much dimension it can increase if we are not careful enough. Second thing, this technique does not consider the ordinal relationship among the variables values. So if we have a height variable, we expect a relationship or order like tall is greater than medium or medium is greater than short. So if we implement this technique, we might lose this information, which changes everything. Hence, this technique can only be applied on a nominal variable and not the ordinal variables. Now let's see the implementation of this technique on an actual data. And the data set that I'm using is the same data that we have been using so far. It is just that I have created the missing values. And the link for this data set can be found in the description box. So we have imported all the libraries and loaded the data. So now let's check the data that how I have created the missing values. So if we look at the data set, we can see that we have missing strings, which means that we have used missing tag technique to impute the missing values. Next, we are going to split the data into two parts, and we are also going to print out the shape of the data to know that how many columns we have. So we have 81 columns. Now coming to the implementation of this techniques, we can do it in two ways. First, by using pandas function or by using sklearn module. So I'm going to show you in both ways. But first, we are going to sample the data because this will be easier for us to check each and everything. So let's check the shape of the data and you can see that we have 5 columns. So to apply this technique using pandas, we just have to call getDummies function and we simply have to pass the data. Note that here we don't have to worry about that our data set contains some numerical values. Now let's see the shape of the data. And here you can see we earlier had 5 variables. Now we have 15 variables. So now let's print out the values taken by these columns. So here we can see that we have 13. So we will have 30 new columns. Now let's look into both the data sample data and the dummy data. Now the first thing you will notice that our numerical variables are intact. Second thing that we don't have original variables. So this method takes care of the original variable as well. Because if we implement this technique on our own, we will have to delete the original variables. But with this method, we don't have to worry about it. And now you can verify whatever we talked in the theory part that how it is working. Like at LA missing, we see 1 and 0 in LA GRVL and LA pave. And same with the other two variables. But notice that there we are seeing all the 3 columns, which means that we have linear combination in the data and we have multi-collinearity. So we have to drop variables. And it is very simple. We just have to call the dummy method. And this time we have to pass data and we are going to pass another argument that is drop first equals to true. And this will take care of everything. Now let's check the data again. And here we see that we don't have LAGRVL and same with the lot shape variable because we are not seeing lot shape IR1. Now let's check the shape of the data. And here you can see that we only have 12 variables because 3 variables are dropped. As of now, we are seeing this technique on a sample. Now let's apply this technique on the whole data set. Now let's check the shape of the data. And here we see that we have 294 columns. Although we have not passed the argument drop first equals to true, but you get the point, right? It increased the dimensionality of the data a lot. So earlier we had 84 variables and now we have 294 variables, which is a lot. And if we check the data, you can see that we have lots of 1 and 0 variables. So this is how we use pandas dummy method for one-hot encoding. Next, we are going to do the same thing using sklearn module. So first we have to import one-hot encoder from sklearn preprocessing. One thing to note that we have to pass only the data which contains only categorical column. We cannot pass the data which has numerical variables. So that's the difference between pandas dummy and sklearn one-hot encoder. So next we are going to create a sample data which only contains categorical columns. Next thing we have to do is to instantiate the encoder by passing few arguments, that is category equals to O2. So this way it will learn automatically that these many are the categories. Next we have to pass drop first equals to true, which we already have talked about. And finally we want to pass sparse equals to false. This way it will return a numpy array. Next we have to fit the encoder on the data, just the way we fit models, and it will learn the categories. Once it learns this, we apply it on the data using transform method. Now let's check the shape of the data. And here we see it has 10 variables only because this time we did not pass additional 2 numerical variables. Now here we see that it returns numpy array, while the dummy method returns pandas data frame, which is more convenient to work with. Since it returns numpy array and suppose you want to work further on the dataset, in that case you might want to convert it into a pandas data frame. And to convert it into a pandas data frame, we have to write this code. And to get the columns, we have to use get feature names and pass the feature name as a string. So now let's check the data. And here we can see the similar thing that we saw in pandas dummy method. Now, if we want to merge this data frame with the original data frame, we just have to call the concatenate function and we have to pass these two data set. So now you see that we have to do a lot of work with one-hot encoder. But in case of dummy method, we just have to call the dummy method and it will do all the work for us. And in most cases, people prefer dummy method rather than one-hot encoder. These both are the similar thing, it's just the implementation is different. So that's all for this video, and if you are new to this channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, stay safe and wear a mask.